wants to watch it later.
Yes.
So that should be recording. So I asked Denise already. Alfonso, did you get a chance to look at the little video?
Yes.
Okay, cool. So you have a little bit of background on it. So let me pull up I'll share my screen and we can go through some examples. So can you see, what can you see there? You see the editor?
Yes. Yes.
All right. So basically, this is a drawing environment that I made to make it easier to do parametric drawings that are a little bit more structured than what a lot of other tools would typically provide. The use case I had in mind was was for like digital fabrication applications, but you can do it. You can use it to make any sort of drawing, and I'll tell you about the kind of drawing model that I came up with to accommodate this. Right now, it's only for doing 2D drawings because I've generally found that in a lot of like fabrication spaces, especially public ones, maker spaces, fab labs, most people do 2D fabrication, specifically like laser cutting, because it tends to be the most accessible. But then in terms of design tools, they're kind of split up into two categories. So there's like the kind of direct modeling tools that most people would use when they're making 2D designs, like Inkscape or Illustrator. And then there's like mechanical modeling tools, which typically have the parametric capabilities. So the ability to like dimension things and define like constraints that can automatically update. And those tend to be in like Fusion 360, SolidWorks, these heavy duty programs. So I wanted it to be easier to make designs that you could easily share. So in this, everything is web-based, and you could just send like the text files, and they retain kind of like their living elements. And yeah, that's what the general motivation was. So I'll go over like what the kind of the drawing paradigm is. Here's an example I think that demonstrates kind of maybe the three main parts of the paradigm to keep in mind. And then we can also do, I'll show an example of like making some slats, which would be kind of a typical parametric design problem. So when you have to have these pieces where you might want to adjust like the dimensions, but you still want them to fit together. So to start with, let me clear the screen. And I'm going to pull up this drawing head. So can you guys see this this orange triangle in the screen over here? Yeah. So one of the main things you're concerned with when you're making parametric designs is dimensions. So essentially like length and angles. And in order to create those, we have this drawing tool that we can move around relatively. So instead of specifying like points for our drawing, we kind of have this this head that we can change the angle of. So I can turn this, I'll turn it to the right 90 degrees, and you see its orientation changes. And then I can tell it to go forward some distance. And using commands to move this head around allows me to make like dimensioned items without having to specify points. So why don't I make a square? Does anyone, let's see, to make a square, what do you guys think I should do next? Whoops.
Down. 90.
Down. Yeah. So down would be, it's already pointed down. So I'll go forward again, and then turn right again, and then do what?
Okay.
Forward again, right again, forward again. So now we've got a box or a square. Now you'll notice that I'm just doing the same commands over and over again. So instead, we're going to do a loop. So this is also I call this a domain-specific programming language. So it is kind of like code. it is code in a sense, but it should be simpler because it's code that is like really designed for drawing in mind. So there's only a few like code constructs that you have to use. But this for loop is just taking the body of it, which is in the curly braces, and doing it over and over again, which is the same thing we had before. So this is one of the main ideas, is having this drawing head. Are there any questions about that? Okay, I can go on if there aren't. Great, perfectly clear.
Yeah.
Okay, so
did you design this program?
yes, I made the program.
Awesome.
Yeah, and it's kind of this notion of the drawing head. It's very similar to a programming language called Logo, which was created, I guess, around the 70s. I should know the exact date. But some of the people who have worked on Logo for many years have been like very influential for me. So you can see that a lot of the Logo ideas are in this language too. But some of the things that are different in Logo, everything is done with the drawing head. In my language, which I call Gram, you can also refer to like specific portions of your drawing, which I call layers. So everything in the language is in a layer. And actually every command that you call modifies the last layer. So if we do this, nothing changed because that's functionally the same, but I can then create another layer with the same stuff, and then I'll change this parameter. And right away, you can actually see some of that utility of having like the parametric design capabilities. Oh, I see somebody's raising their hand. Isha?
Yeah, I have a question.
Yeah, go ahead.
Like when I am opening this link Protoplum, nothing is visible on my browser. Like just the page opens, but other things are not. It shows a blank page.
Sure. I'm happy to help you troubleshoot that. The first thing would be, yeah, I don't know if you want to follow along now, I could try to suggest some quick fixes. What browser are you using?
I use Firefox and Brave browser. In both, I have similar problem. I am using Ubuntu 20.04.
Okay, that's useful to know. I think that I do most of the development in Chrome. So it's possible that that's the issue. Do you have JavaScript enabled? It
how
would
to
be
check? Brave is Chromium based.
No, but Brave comes with a default privacy and ad blocking features, so it might be blocking some of the JavaScript.
It could be that so I'm using like JavaScript modules, and it might be possible that it requires like HTTPS certificate, in which case I just would have to change like the hosting location. But the actual the whole everything runs like client side. So like any kind of JavaScript compliant browser shouldn't have any issues with running it. So worst case scenario is you can just like download it and run it locally, which would be fine. But that would require a little bit more assistance to get going right now. I'm just checking how it looks on my Firefox. It is also possible that I just have, some bug with the rendering system, which has happened in the past, which I'd have to fix, which is useful to know. But let's see here. Okay, yeah, so it works fine on my Firefox. So I'll check in with you later, but let's keep the flow going on the lesson now, and then you can just have this to reference, but you won't be able to follow along, unfortunately. I think if you downloaded Chrome, if you weren't, ideologically opposed to doing that, it probably would run okay. But otherwise, I can just follow up with you and try to troubleshoot that.
Okay.
Does that sound good?
Yeah, that's fine.
Okay, great. So we were talking about layers. What the layers allow me to do is to basically, I said that like every command that I run modifies the current layer. And so I also have commands like translate or rotate, or these things that can modify the geometry. And wrapping that inside of the layer makes it so that it will only affect the layer that this translate command is inside. So you see, if I take this and I move it to the top level layer, then it's going to move both of the squares. And if I put it inside here, then it only moves one of them. So that's one of the other key ideas. We have the drawing head for the intrinsic reference frame of drawing things, which allows us to draw shapes with specific angles and dimensions. And then we have the layer system for essentially making it that our commands will only modify a portion of our drawing. And then maybe the last important idea is that you can also reference. You can name portions of your drawing, typically layers. So we'll call this first layer. And then I can reference this first layer for other parts of the drawing. So if I want to move my second layer, which, to make this a little bit more clear, I'm going to give this a color. So the second layer is red, and the first layer will be blue. And if I want to reference the first part of my or my blue layer in my second layer, then I can do something like move. And there's origin points, which is the default demo was showing the different origin points, which are basically like the corners or the points in between the corners. But I can move the center of my red square to the right top of my first layer. And now you can see how I can do relative positioning. So with this, it allows you to take multiple shapes and link them to each other parametrically. So now if I go back, hello, welcome. So now if I go back and modify my first layer, then you see my second square still stays like stuck to that top corner. So this can be a very useful thing when you want to compose pictures that have multiple elements in them. So I would say that these are some of the core ideas of like this model of drawing, which hopefully will allow us to construct these dynamic pictures that we can easily share with people. Does that make sense, what we're talking about? Any questions so far? Great.
So what is
Crystal
this?
clear. I'm sorry?
This kind of drawing, what is it similar to? Like, do we have these features in any other software?
That's a good question. So what I'd say it's most similar to is something like Logo, which I referenced before. There is some other software which has some similar ideas. So Brett Victor, who's a excellent like UI UX designer, it's selling him short to call him that, because he's an amazing engineer as well, and generally somebody who I highly recommend looking into. He's got a bunch of great talks online, the best known of which is probably Designing on Principle. But he's very influential in like the alternative programming space, and a lot of the stuff that he talks about is embodied in this in some form. So that can be similar. He's made some prototype drawing tools. I know of some other people who are kind of in that world as well, who have made some similar tools. But trying to refer to something which is maybe more widely used, there are some aspects of Figma which are kind of similar. I don't use Figma very much, but it's a design tool that recently it's designed for creating like applications, essentially, mostly for web design, but it's really just a good design tool in general. And they have a constraint system which essentially maps to CSS, and they've kind of rephrased a lot of the stuff, but it does directly map to like CSS concepts, and some of that is similar in terms of the positioning. But off the top of my head, I'm not sure of something that integrates like all of the same ideas. So for me, like what I wanted to capture was like the positioning aspect and this ability to specify dimension. And one reason is that most of the time when people are doing like dimensioning, either they're working in like in a typical CAD program, dimensioning would be done through a geometric constraint solver. So you would have like these systems of equations essentially that you have to solve somehow to like figure out where all of your geometry could go. And that's a very different paradigm of addressing this issue of like, how do you locate points relative to each other? So I would say that this is more of like a constructive approach, where you're providing like a description of creating the drawing, which makes it kind of easier for the computer to actually solve the problem, because they just follow the instructions that you laid out, rather than having to solve for like unknowns. And that tends to not be used as much for these purposes. So that probably was too convoluted an answer to what your original question was, but hopefully, is that informative?
Yeah, because I also use some JavaScript based solutions. They never seem to have this relative concept, the concept of relative positioning, and it's very useful to have.
Yeah, I certainly think so, and I think that's definitely, I mean, it's an observation that I've made. So I think you're on track, like pointing that out too. So one reason for that is that most of the time when people do like scripting geometry, so you might think it's similar to like OpenSCAD or something like that, or OpenJS CAD, and it is in a way, in that it's like this kind of code-based description language for geometry. But oftentimes those like code-based tools, they work in like a Cartesian reference frame. So you specify like points, and you have to like do all of the parameterization like through the same reference frame. Where what's different about this is that it has more of a notion of things being like relative to each other. So you can reference like other parts of the drawing and do things relative to that. And that's for dimensioning or for positioning. So this is just a really basic example, which isn't necessarily going to be something so useful to make. So let me pull up something which might be a little more interesting. So this is a system of slats, which you could press fit together to form a grid. And this would be a pretty classic like parametric design problem, is design a press fit system. So this is one of the most basic versions of that. Potentially it could actually be a useful object too. Does anyone want to describe how they see this fitting together?
I'm sorry.
So you can see that like these are components of a thing. Does anyone want to take a shot at describing like how this would actually go together? So right now we're like looking at a cut sheet, but if you were to cut out these pieces and assemble them, what sort of object would we have?
We'll probably have like what do you call that? Like a window pane.
Yeah, I would call it just a grid. Maybe there's actually a better word for it.
Exactly.
Yeah.
Yep.
Yeah. So that could actually be kind of have some functionality. You know, you could use it as a desk organizer. So you might want to parameterize this drawing because you have a certain drawer that you want to put in like some organization. So you need to put in the dimensions of the drawer. So, you know, if my drawer is a little bit thinner, then I'm going to want to adjust this parameter. Whoops, and not blow it up. So now I have a thinner grid for organizing things in a smaller drawer. So you're starting to get hopefully through this, you could see some of the utility of having a parameterized drawing. Why don't we try to go through actually constructing this? And I was thinking that this might be an interesting example to show as well, because we're talking about like home lab setups, and potentially, you know, one interesting application of this environment would be, well, a lot of the motivation for it was creating designs that people could more easily share and then customize. And it could be nice to use it for this home lab setup question, that we could be designing pieces of equipment for our home lab. And they might be simple organizational things like this, or they could be, you know, more involved apparatus. But we can make them so that other people can customize them for their lab. So like one thing you might want in your lab is like an organization shelf, you know, and it could be nice to create designs that people could easily take and then just make it so it fits perfectly on their desk. And now they have their own custom shelf. So that was one thing I had in mind, that perhaps if people want to play with this later, they could try making some of these home lab pieces of equipment and sharing them in the group. So why don't we go through trying to construct this? And unfortunately, my basic Zoom.
Is this object oriented? Can you create you know, the objects, properties, attributes, those kinds of things?
I would not call it object oriented.
Classes, yeah.
In a sense, so like the philosophical difference between like you know, an object and some other paradigm, you know, functionally oriented paradigm, is not always entirely clear. So in some sense, you could think of these as being objects. My original conception of them was more as functions, but it depends on what you would catalog as like the state. But that's a more almost like philosophical discussion, which is maybe not getting at what your original question was. I would say it's not, because you don't have like,
not right now, maybe.
Yeah,
because I think,
go ahead.
I've seen that so many of you know, these software projects, they tend to go towards becoming object oriented, and they have, you know, classes and stuff like that, but functions always seemed very intuitive for me before getting into classes.
Mm-hmm. Yeah, I would agree with that. Yeah, I don't think it's necessarily a concept that's necessary to invoke. And we don't really need that sort of like state encapsulation either. So one thing is that like all of these drawings are modules. So this drawing, like I could import this drawing into another drawing by referencing the URL, and and then I could just pull this in, and like whatever parameters of this drawing function would then be available to me in my other drawing, which is maybe a more advanced use, but that is an important thing about the program, that like anything you make, you can easily share and easily reuse in a different drawing. But why don't we try to construct this while we're here together and still have a little bit of time before Zoom penalizes me for not paying. All right, so we got to look at our grid. Why don't we try to make a slat to start off with? So how would we go about making one slat? And we don't necessarily have to worry about getting the dimensions exactly right in terms of the parameters we're interested in, but let's just get the rough geometry. So we'll start by going forward, and then let's go right, forward 90, right. All right, so now we've got one portion of our press fit, groove, I guess we could call it. And we want to repeat this. So, well, one thing, we know that we're going to be reusing this groove multiple times. So why don't we actually enclose this with another name?
I hope people are familiar with press fit.
With what?
Press fit.
Press fit, yeah. So to enclose this with a name, we're gonna define this variable, and then to create like a function or a block, which we can call again later, I'm gonna do a colon and then curly brace. And now everything in here is gonna be run whenever I call step. So now if I want to do another step and then another step, so now I can do a bunch of steps. And
You probably, oh.
So if I wanted to form the other portion of this, what might I want to do? Or how else might I want to modify this if I want to turn this into a full single slat? Any ideas?
Create a function with a for loop.
Mm-hmm. So now that's doing the same thing that we just had before. I can do more. We noticed that the ones on the end are like only half steps. So that maybe is what we want, maybe not. Probably we want our steps to be roughly the same size. Let's see if it would be nice if I could share another image so we could see what we were going for. Why don't I pull up the previous slat?
What are you trying to do?
I was just going to pull up again the example that we were looking at. So if we're trying to make something like this, and just get fewer of these. So let's say we're trying to make something like this, and I'll take off these fillets too. We don't have to concern ourselves with that for now. So this kind of basic example. And what we currently have is this. So our steps are a little bit longer than we would prefer. So one way we could adjust
I think
that.
you can remove the forward right, initial forward right.
Forward right here.
No, the first two
This
lines. Or the last two lines, yeah. Have the same effect. Oh, wow.
So let's see.
Interesting.
So now we're getting a square. So that's not quite, but I think I see kind of what you're saying is like starting
Yeah,
here. Yeah, what I
yeah,
might
we need
do
to-
is, so we're repeating like this portion. So maybe what if we made this last step, instead of being the full length, what if we made it half as long? So let's see if we can see. So that's going to be this one. And why don't I give these. That's the height. That's the bottom. And then this is this top step. So let's make this, we'll call that the top. And then we're going to do this one, top divided by 2. So now when we do this, now all of our steps are roughly
could also start from the half of the length.
from half of the length, which would be, whoops. So are there any ideas about what might be off about this? So our first step is,
you want the width of the slots to be same as those of
they don't
those
have to
teeth?
be. So the bottom width can be smaller. But what we would like is for this length to be the same as this length. So right now, it's not quite the same.
Oh, you're changing the fraction.
Yeah. But if this is the top, or we could think about,
You can define a variable called top and then start with top by 2 and end by top by 2.
Yeah, so it seems like that should be what we're doing here. So I think that the issue is that we also want this to be.
Yeah, so I was saying we should declare top as a different variable, then use it in the forward statement. In the
Sure. So let's make it a
top by
parameter.
2.
So the first thing, the issue is that there, and it's not super easy to tell necessarily, but what I was trying to show is that like the whole statement is being tacked on. So we're going forward, forward, and then forward again. So the first forward is only once, and then all the other intermediate ones happen 2 times in a row.
So instead the first forward could be half. Yeah.
Yeah. So what I think that you're picking up on that. So for our top, why don't we set the variable here? And it would be preferable to pass it in as a parameter. But we'll do top, and then we'll add our forward. Is this what you were saying?
It still doesn't end up with the same length. Yeah, yeah. What do we
Mhm.
have here?
So now if we change
So we
this,
change the draw. Yeah.
yep. So now we want to close this up. So to close it up, we're gonna go right. And I think we're gonna get kicked off soon from Zoom, but I'll just keep talking until it
We
happens.
did get a message that the meeting is no longer time limited or something like that.
Oh, really?
Yep.
Interesting. I did not notice that. Well, that's good. So we can just keep talking forever or until you guys are completely tired of this. But let's
This
see.
is too interesting. Did you tell this to Neil? Does Neil know about this?
Neil Gershenfeld?
Yeah.
No, I haven't showed it to Neil yet. I'm sure I will at some point. I sent it to Jake the other day, who's one of Neil's graduate students, who I helped out with some projects last year. But I haven't really gotten the time. I haven't found the chance to
Sure.
get his thoughts on it.
Because Neil would love this actually, and
Yeah.
he would also, promote it in Fab Academy.
Yeah, that would be. I'd love if that was the case.
Yeah, you get good feedback from people using it.
Mhm. Yeah, it's still in active development. So I appreciate you guys. Maybe you didn't realize you were volunteering to be guinea pigs, but that is maybe what's happening. So I appreciate it a lot if anyone wants to use it and get feedback. And also if you want, your features, let me know and I can add them in. So let's try to close this up. Now, let's see. We want to go back to the beginning. So let's go forward. There's a special variable called current, which references like the shape that we're currently working on. It's basically what we see on the screen. So I'm going to go forward the width of the current shape. There we go. So that brings me back to the right X value. Then I'm going to turn up again. And there's a bunch of different ways I could close it. I can just call close path and that will go back to the origin. Or if I wanted to do a similar thing to what I did before, I could go up to the height. That also works. Or I could go to the start of the shape that we were drawing. So great. Now we have a single slat that has some variables that we can play around with. So why don't we wrap all of this in a slat function? And let's turn some of these, let's turn top into a parameter that we pass in. And let's also turn the number of tabs into a parameter that we pass in. So then if I do slat with tops of length 40 for tabs, great. So now we've got this variable slat. Now we get to copy and pasting, or like making copies of the same shape and then modifying them. And the way that we do that is we have a function called copy paste. And with copy paste, I pass it a number, which is the number of times I want to copy it, and then a body, which gets applied to each copy. So for each copy, I just want to get a better look at them right now. So for each copy, I'm going to translate it, and I'm not going to move it anywhere in the X dimension, but in the Y dimension, I'm going to take the current shape and then move it up by the height of that shape. And then we'll add, let's see what that looks like. So that's that's about what we would expect. So we've got our first shape, and then we have 4 copies, so 5 shapes in total, and each one is translated up by the height of the last one. So if I wanted to space them out a little bit, what could I add in here?
Add the length of the space.
Sure. Great. So now I've got them spaced out a little bit too. So now we have sort of half of our slat system, or yeah, we basically we have like one dimension of it. So we want to make another set, which is going to go the other way. Does that make sense? So like right now we have like, let's say we have all of our X ones. And so if I'll try to demonstrate this with the drawing. So if I copy and paste this once and then rotate this 90 degrees around the center, and then I'll translate that over. We need a set of slats that will also like fit in the other way. So now we're going to get to the point where we start to care more about like how we reference those parameter values driving this design. But let's see if there are any questions about what we currently have, because I think that's covered a fair amount. And it might be a good exercise left to the user as well to try to parameterize this in such a way that it's being driven by parameters that you might want to input, which I would say, one example of that would be like right now we're giving the dimension of one of these steps, but what we might be more concerned with is the dimension of like the entire thing once we put it together. So we're going to want to give that and then like figure out the formula for a step from that parameter that we're interested in. But I think that will probably not be the most interesting thing to watch. So we don't necessarily have to do it right now if people feel like they've gotten like an idea for the core drawing model that we're looking at. But so why don't are there any questions, or do people have any shapes in mind that they might want to try to work out trying to construct with this system? I can do it with you like right now. So if you have some sort of idea or you want to draw something, yeah, go ahead.
Yeah, so these usual CAD models have primary shapes, primary solids, primary shapes, circle, triangles. So are there functions that directly invoke those kinds of shape?
So the main functions are, we've got our line forward. We have arcs. So the arc will take an angle and a radius, and this is a portion of a circle. And we can chain these together to make smooth curves. And then from these, you could pretty much make, you can make probably most of the other shapes you'd be interested in. I do have a square. I may have rectangle built in. Actually, I don't have square. I might have rectangle, but they're pretty easy to reconstruct. So the only other one, like arc and line are the main primitives, and underneath everything is a polyline. So everything is constructed just with like little line segments. But arc and line are the main primitives. I think that's probably the better way to think about it. There is some like syntactic sugar for a circle, and I think also a rectangle right now. Let's see if that still works. Yeah, so the rectangle as well. And but what I think is another good exercise is if we make a shape generator for doing like the other regular polygons. So why don't we do that after this? I'll show you that we also have a round corners function, which we can see here can round out the corners. So it fillets all the corners of the polygon that we're working with. But let's make a shape function. So the very first thing we did was the start of a shape function, actually. We had a for loop, and we were drawing a square. So a square was forward, and then right 90. So this is the beginning of a shape function. Now, if we wanted this to be, you know, for, let's say instead of, so the shape, we're going to pass in some parameters. So we'll make a function. Oops. And then let's pass in the number of sides and the size. So those should be two parameters that, you know, give us the good values for driving like different shapes we want to make. So if we're looking at this drawing now, let's call make shape. And right now I have to pass in the parameters, but right now they're not being used anywhere. I'm kind of giving you hints for the next question I'm going to ask. By the way, I just wrote that. But if we wanted to take our square and abstract it a bit to turn it into a shape generator, what might you want to change here in terms of the parameters that I set up? So we've got a for loop, and we're going to turn that for loop into something which can draw a shape with a specific number of sides. So if I passed in 3 and 8, then it will be a triangle, you know, so a shape that has 3 sides, which with each side length of 8 units. And in this case, the units are millimeters. That's the default unit. So let's see, what are we going to change in make shape? Right now it's make square. Well, right now I'm passing in 4 here for a number of sides. So if I replace 4 with that, and forward is the only unit of length, so I'll replace that with size. So now if I do that, I still have a square, and I can change the dimension of the square. But if I change the number of sides, I do have more sides, but they just keep running over each other. So that's not quite what we want. And we only have one number left here to change. So we're going to want to take this angle, which represents these angles in between the sides, and cast that in terms of the parameters that we're providing. It's not going to be dependent on the size, because that's just this length. So that doesn't really have anything to do with this angle, because, you know, we can change this and these angles would stay the same.
So it's 360 by n by the number of sides.
Yeah, exactly. So 360, because it's going to form a closed shape, and then divided by the number of sides. So that makes sense for that one example we were just looking at, that we can see that we were taking a 90-degree turn. So 360 divided by 4 would be 90. So now if we do this, whoops, 0 is going to crash it. But let's see, if we do 3, we have a triangle. If we do 4, we have a square, 5, so on and so forth. And now we have a regular polygon generator. So that was a 10-minute answer to your question of if it has built-in shapes. For the most part, no, but it is easy to make them. Maybe I'll add the make shape function if this is used often enough, and then it will have built-in shapes. Yeah. Now,
You
let's see
haven't,
here.
right, go on.
No, go ahead.
What about Bezier's?
It doesn't have Béziers. Yeah, that's a more, so Béziers are parameterized slightly differently in a way that I haven't yet decided. I have some thoughts about Béziers. Other design tools I've made in the past have been like based around them. I didn't include them in these, but still up in the air of whether I will. Yeah, but let's see if we want to do an exercise. So let's say we want to take these shapes and make a line of different shapes with like, increasing number of sides. How might we do that? So often when we're doing an iteration, it's helpful to start with the first couple instances. So let's say first I'll start with a triangle, and then I'll do a square right after that. I'll make it the same side lengths. So right now they are on top of each other, and that's not necessarily what we want. So let's enclose this on a layer. And move it over. Okay, great. This layer, it might be useful if this layer was actually inside this function so that every time I called it, I was making like a new shape and it wasn't modifying the whatever current shape I was working on. So let's do that. And then I'll still need this to modify it. Now, if I want to do this iteration where I'm changing, this argument each time, I'm going to have to make a loop. So let's do 4, and we'll do 6 shapes. But one issue here is that the first couple values, like 0, 1, 2, those are not going to create polygons that we're interested in. So we actually want to start at 3. So the for loop, it can take one number. It can also take an array. So if I wanted to start at 3, 4, 5, I can do that. I can also describe that as 3, 2, 5, and then let's do this. And if I want to reference that iterator value, then I'm going to say as I. And then we'll make our shape. And we'll call each one with I. And let's see what we got there. So that's doing up to 5, but not including. So let's do some more. Okay, so now we're doing these shapes, and we want to move them over. So let's choose some spacing. And that is not exactly what we're interested in. So we are going to need to, but maybe it could capture the right idea. So this isn't quite the regular spacing that we would want. Part of the issue is that, well, one, when we translate, there's a couple things going on here, but this translate is getting called on like each shape multiple times, as opposed to just once for each shape. So we'd have to enclose this in a layer. And then they're all getting translated by the same amount. So now we're going to want to multiply that by the iterator value. And now the later shapes, the shapes with more sides are getting moved over more, but we don't want to move them by the same amount necessarily. So there's a couple ways that we could try to address this. If we're going to do translate, why don't we start by creating a value, which we'll just call move over, and it will start with 0. And we'll move each one over by that variable. So it's always 0. Now, as we do that, why don't we update move over each time with the current width. And this is closer, but not quite what we want. Let's see if we move this up here. Better still, maybe not exactly what we want. But we're coming up on an hour. So I might leave it as an exercise to the reader to work out how we might want to describe moving each shape over so that the next shape, the right-hand side or the left-hand side, just barely touches the right-hand side of the last shape. And to give you a hint, the way that I would ordinarily do it would involve one of those relative positioning descriptions, which would mean that I would probably be using move, and I would be moving the left center to some value of the previous shape. So that would be the previous, and that would be the right center of the previous shape. So right away, we have most of the description of what we're going to need to do, and that would be instead of the replacement. But I'll leave it to you guys to figure out how to get that to work just the way we want it to. Are there any more questions?
I always have questions.
Yeah, go for it.
So it's interesting that you have, like it seems redundant that there is a command for direction, and then there's a command for going forward or back, which need not be the case. It could be a single command which would just say angle and length, right? But
yeah.
But I get it. Like I get it. Like from where I come from, where I generate a lot of CAM codes, the direction of the shape is important. One will be clockwise, the other one will be counterclockwise. That's how the CAM works, and that's how I can feel that it's important. But is there any other logic behind that?
Yeah, you mean the logic of separating the angle and the length?
Yep.
Yeah. So actually, I originally, I do have the command for what you're thinking, which is turn forward. And originally, this was the one that I always used. So this is the same as like changing the angle and the length. And I like this construction. So that's more of a kind of historical contingency thing in a way, where the reason that I shifted over to like separating those was because I was spending quite a lot of time speaking with people who developed Logo, and in Logo, they're separated. But originally, I liked this turn forward description because this is when I read this, I don't necessarily see it as a description of like moving that head around, but it's kind of a description of the line that it makes, just in like
Yep.
terms of a vector, where it has, you know, a magnitude and an orientation. So yeah, it's interesting that you say that. I also like this form. Part of it too is like, you know, when you're talking about the language, or you know what I would call, and like what the terminology I've been using with other people when I discuss this is the meta language surrounding the language, which is basically like how do you talk about what's going on, or how do you teach this? And I found that the meta language changed from when you were talking about turn forward or like the vector construction of the lines, then the way that people thought about it was that it was a manipulation of the line as opposed to a manipulation of the head. So trying to convey this idea, which is like one of the central ideas of having this drawing head that you're manipulating, was sometimes less clear with this description. And that was partially why I like separated the two. But I think in some ways I'm like more partial to this. And at some point I'd like to develop, in the near term future, I'd like to develop like more of a structured editor where you can see here, like I have these manipulations that run in real time when I drag the parameters around. But let me show you another project of mine, which was a very early iteration of this. So here was an old iteration of this, which has like a similar, slightly different drawing paradigm. And you can see in this one, the commands are linked to each other. So here's like, you can do it as a data flow program, and then you can edit the nodes in this little editor here. But we don't have to worry about that right now. But
Neil Gershenfeld has created a similar software called, I mean, he has done both the softwares, like the one which you're trying to explain, the grams. He has created a software similar to that. It's called Cocompe or Cocopelli. It's called both. Have you heard of that?
Oh yeah, I'm very familiar. So I think maybe you're thinking of mods for the data flow stuff. Yeah. So when I was helping out Jake with, I just was making a tiny contribution to what was his master's thesis, but that was called Squidworks, or Cuttlefish, and that's kind of like the successor of mods in a way at some point down the line. So a lot of what I was doing was like digging into mods and taking, you know, specific modules and pulling them out. So I'm quite familiar with that project. The internals of this are a bit different than mods, and the way that like the graphs get evaluated as well. But it definitely, like that's a keen observation to see that similarity. This I started working on, So yeah, I definitely have appreciation for it. But the reason I was going to pull this up is like I could consider this a form of like a structured editor. And the thing that I would like to transfer in like the next iteration of the Gram structured editors, where like you have the language and then you have like programs for creating programs in the language, is the ability to do these direct manipulations which backpropagate variables into the program. And so I like this feature where it's like I can just drag this line around and I can basically I can make drawing tools that construct these programs. And when you have this sort of tool, the description that you were mentioning, which is like describing the forward turn or the turn forward in one command, makes more sense because it's referencing this like unit of line, you know? So yeah, I appreciate that comment. And I think that at some point in the future, maybe not the too long future, you'll see more of like that construction, that description of it. Yeah.
I also have a general feedback or about the direction of the software.
Yeah.
I use AutoCAD a lot and AutoCAD clones. So there is SolidWorks, sorry, Dassault Systems draft site,
Hmm.
and I'm very familiar with. I'm very used to how they treat vector drawings. So similar to how you have turn forward, they have their own commands. It would be very helpful if if you could just have a look at them and then create something similar to their flow. It'll be very easy for us to just switch from that paradigm to something you're creating.
Yeah. Are you referencing so I'm more familiar with like the sketching tools in those programs, but are you referencing like scripting features in them? I know for a long time.
Not the scripting features, just the like if I when I use AutoCAD, I barely use mouse. I use mouse to uh, give a direction, and mostly I just type. So if I want to type, if I want to draw a line, I just type line in the command editor, and then I can start drawing polylines and give a direction, give the length, and then next polyline segment I just give the direction and length. So I can just create the shapes just by cleverly manipulating my mouse and the commands which I give. So it's very good for productivity. So like have you used AutoCAD?
I have a while ago,
Have
but
you
I'm
used
not as
the
familiar with
command editor
AutoCAD.
a lot?
The what?
Command editor.
Not so much. I have in the past, but I'm certainly not super proficient with it. I would be curious if you wanted to at some point like show me the workflow that you're talking about. I think I have a
Sure.
sense of what you're describing, but it would be useful to like actually see you do it. And I could try to capture more aspects of that if you think that would be helpful to people.
Sure. And AutoCAD and such softwares have already figured out a lot of ways to increase the productivity. They know um, uh, like how do you add features in command modes. So better like they have the path flows. If you want to create something, they have a very good like if you want to create a rectangle, they have so many ways to create a rectangle. Is it from center? You just mentioned the length, center and the length, or is it from the corner to the length? So you draw from the corner, and so all these things they are the UI and UX part, they are already figured out. So it would be very helpful for you if you just go through them and then try to just imitate them. It'll instead of doing it from the scratch.
Mm-hmm. Yeah, that's a useful idea. We could chat another time, or if you want to just do like a screenshot of a quick example drawing, not a screenshot, like a quick screen recording. I don't know if you know how to do that. Yeah,
Sure,
both of those would be super helpful. Yeah.
Hey Leo, solid effort. Thanks for the class, of course. Hi, I'm John. I was just wondering. I mean, I missed a bit of the class. I joined a bit late, so you might have already covered this. But is there like a vector to raster converter that you can directly use in JavaScript? I believe this is JavaScript, right?
So it's a domain-specific language with a interpreter that's written in JavaScript, but like it runs in the browser. Yeah.
So do we already have a so the interpreter is already available, is it, or is it like an open source interpreter that we might use to rasterize?
So it's new. It doesn't do rasterization. It's for constructing vector images. It is it's very new. so it's something that I've been working on this
Mhm.
past couple months, and it is like freely
Mhm.
available at the link, which was in the video description. I can make the link. I'll
Mhm,
post it
mhm,
again in the
mhm.
chat.
Mhm.
And it is, it's poorly documented, but it is open source. So I'll be improving that documentation in the near future and making that more readily available. But that is the intention, that it's
Awesome.
an open source project. Yeah. And I think
Mhm.
in some ways, I'm still playing with the idea of actually making it more of a file format for these sorts of dynamic drawings, because they're, this gets into like a more technical discussion, but it doesn't necessarily require the runtime.
Mhm.
So that could be another interesting way of thinking about it, is that it could be like an alternative to an SVG format in a way,
Mhm. Mhm.
as opposed to requiring like a program that's actually running. But it is also very small, so it could be possible to embed it in like other, Inkscape or something else.
That's right.
Yeah, but I
Mm.
hope, does
I
that
mean,
answer your questions?
Yeah, it does, of course. Yeah, and my experience with this is just whenever I need something, I just type some these into MATLAB and save it as an SVG. That's what I've been doing. So I do like this is quite valuable because it works on the browser.
Yeah.
And good call about the default name, file name. Anon. Cool.
Sorry, I didn't quite catch that. You said you like the name?
Oh, of course, yeah. It's
Oh,
it's
great.
quite the trending name. Yeah.
Yeah. Yeah, thank you. The name is, I don't put too much bearings on names, but Graham, so it's a reference to, I don't know how to pronounce it, but like a lot of this is logo inspired. And logo means word in Greek. Graham is line. So because everything is lines, I called it Graham, but also because it's lightweight, which is like a buzzword for like all JavaScript based things these days, is calling them lightweight. Yeah, but I appreciate that. Yeah.
Awesome.
And yeah, I definitely love, like, it's available. I'll send the link again. But the interpreter is available. It is like actively being developed. So I can't promise that, like, if you want to make like a super elaborate thing, you might have to occasionally modify it. But the general like model of drawing will, I think, remain the same at this point. So it will be like more smaller syntax changes. But I'm super appreciative of people if they want to test it out and make like smaller drawings to share with the group. I'd love to see that. It'd be really helpful for me. I think that it's a useful tool, but I'm definitely at the point where I need other people's feedback. So hopefully it has value for you, but just you using it would have a lot of value for me.
It's quite valuable. I mean, parameterization in itself in any form is quite valuable, but because it works on a browser, it's extremely valuable. Yeah.
Great, thank you. And yeah, and it's interesting the thing that you described about you said for making ellipse, you often go to MATLAB, and that was also one of the things I had in mind. That was like in a lot of CAD programs, when you have like there are some geometries which are simple to define but like hard to draw.
Yeah, exactly.
And so for me, like one of the prime examples of this was I was working on this open source machine building project in Norway, which had these great machine designs, and there was a very distinctive drive system which involved a rack and pinion. And it's a cycloidal rack and pinion, and there were great engineers and designers working on the project, but we had these very idiosyncratic ways of generating these racks, which were like actually quite simple to describe. And so I just wanted like an easier rack generator, and just being able to like specify this like a couple trig functions that would capture most of the geometry was extraordinarily useful. So that was one of the first things I started making this for. but it's amazing how difficult that can be in a lot of other tools to just be like,
Oh,
I just need a trig function.
yeah.
Yeah.
It's quite relatable, yes.
Mhm.
I mean,
Great.
there are other ways to work it out too, but if we somehow build a Bezier function into this, I mean, we could use anything that, I mean, since it's working on a browser, I mean, memory might become a concern for us. So dealing with complex geometry, you might not need to have a lot of points to, I mean, you could use something like the class shape transformation. So it's just maybe with 4 different vectors, so 16 elements or something, you could just make a very complex airfoil shape. So that might be, yeah, so transformations, class shape transformations. Like, so you have a class of shape, then so that can be defined just like this make shape function, and a set of transformations. So yeah.
Yeah, and I'm always open towards like, you know, other types of transformations that might be useful. I think that there's a lot of interesting work in like computational geometry that could be incorporated, yeah, to some degree. Yeah.
I think in a few years we could even do 3D quite easily with something like the polycubes method. So it's basically you're wrapping the 2D. I mean, it's like you have this net for a cube. You divide the entire thing into cubes and unwrap the cube into the 2D mask. So I think this can go a long way. The tool is worth $1 million. Yeah.
Yeah, I mean, if any of you are developers as well and want to contribute stuff, I'm also open to that. So I won't.
It's my engagement is just need based. So when we need a particular shape, I just think about it. It's a computational geometry way. That's all. So yeah, I would love to chip in if I have some ideas about functions and complex shapes. Great.
Cool.
So thanks, Leo. I think I have to go now. It was quite fruitful. I'll catch up on the first part later from the record.
Yeah, thanks everyone for tuning in. I'm gonna have to head as well. But you guys know how to contact me on Discord if you have some questions. And yeah, I'm very, very appreciative of your interest, curiosity, and letting me spend an hour and a half talking about this. Great.
Thanks a lot.
Yeah.
Thanks, man. Thanks, Leo.
Again, a very bye, everyone.
Interesting session. Loved it.
Thank you. Have nice weekends.
Yeah, you too.
Bye.
You too. Thank you.